This is the afternoon lab activity on May 10. You're asked to generate this geometry and then perform a finite element analysis on it. We are assuming the material that this is made of is brass, and as far as the loading goes, the inside of this hole is clamped, and a pressure of 2 MPa is applied on that face. Now you're told that you have to use as many planes of symmetry as are applicable in this particular problem. And in this problem, it is obvious because of the nature of the geometry and the loading, there is one plane of symmetry, and that is cut this thing into two halves. So what I'm going to do is I will actually make the whole model uh, and then use an appropriate plane to split it or cut it into two pieces. If you want, you can also make half of it, but for me, it's easier to make this thing exactly like what it is and then uh, cut it or split it into two pieces. Okay, so the geometry is here, the dimensions are there, and I'm going to look at my paper, not go back and forth between these things. So the strategy that I'm going to follow is first I make this base. You see that base is that horizontal piece, and then add this thing to it, tombstone to it, and then eventually make a hole here by cutting it, pocketing it to create that little indentation at the bottom. Okay, so that's my strategy. First, we start with the part file. Please make sure you save it immediately in an appropriate place. So file, save management, save as. I'm going to I have already made a folder called afternoon lab activity, May 10. So I'm going to put it there, and it's called part one. Make sure you don't overwrite other things by just being lazy and calling it part one. Because there may be another part one there that you're going to get rid of if you do this. But anyway, that's fine. So the units, assuming that, let me see now, the units of this thing are the millimeters. I have already changed my units to millimeters. Uh, you already know how to do that. So on that horizontal plane, I will sketch something that resembles that piece. So right now, I'm not very fussy, so I'm just going to make something and then clean it up in a minute. So something like so, and there. Okay, so let's see now. Left line, control right line, control middle axis. I'm going to make it symmetric. Okay, that's good. And then uh, how about giving some dimensions here? Maybe start giving dimensions. So let's see now. Oh, let's see. What do we have here? This is 24. This is 20. Sorry, 22. So it looks like this size is 22, and so is this one. 22. Okay. What else do we know? These radii are also 22. This radius is 22. Yeah. And this radius is also 22. All right. And I want this thing to be tangent with that. So this left line, control that arc. Yeah. And then I go here, make a tangent. All right. And what else do we know here? The whole thing is 110. This whole thing is 110 inches. Not inches, millimeters. Okay. And that's pretty much it. So we also have two circles at these locations. So one circle like that, and the radius of that circle is, by the look of it, is 5.5 for diameter 11. So This is going to be diameter 11. Okay, and because I'm too lazy to make another one on this side, I'm going to mirror it with respect to that vertical axis. So here's the mirror option. This with respect to that. So over on the other side. I think that's pretty much it. So exit, and we pad it. You can look at it like this if you want. We pad it by 13 millimeters in the other direction. 13. Very good. So that's what we have. Now I'm going to make that tombstone on that side. So on here, I'm going to sketch. All right. So it looks like I have something like this. We'll clean it up in a minute. All right. Oh, let me actually close this. Close meaning using a line from here to here. Okay. And then you make it nice and symmetric. Left line, control right line, control middle axis. You make it symmetric. Okay. And now we put some dimensions here. So for example, let me see the dimensions. Let me also draw a circle there. The radius of that circle is 8, or diameter is 16. So this is diameter 16. Okay. The radius of this circle is 22. Okay. Now these heights, let's make sure we know what these heights are. It looks like the distance from the center of this to the bottom is 37. So I'm going to make a dimension from the center of this to that bottom line, 37. Okay. And we have to know what, that's pretty much it. I think this is actually what we've got. So exit. All right. And then the thickness of that is the thickness of this thing after padding is 11. Right. So this is 11 in the other direction. Okay, good. Now we have some fillets here. We can use surface fillet. So let me see now. Actually, it's not called surface fillet. It's called, let's see now. The name of it is, it's in the dress up features toolbar, and it is, what is it called? Edge fillet. So I select that guy, and I put a radius of 10 based on the drawing. The radius of this fillet is 10. Okay. And same thing on the other side. I can mirror that on the other side, but the easier way is just do this. Okay. So we're good. I don't think I've missed anything. That's what we got here. Okay. Oh yeah, the pocket. Let's make sure this whole thing is 110. I think I made it. If not, we're going to measure it. So where is this measuring thingy? The measure icon, I don't see it here. So let's go, maybe it's closed. So let's go here to view. Toolbars, is there a measure somewhere? Yeah, measure right there, right there. So measure the distance from this point to this point should be 110, and it is 110. That's good. That's good. Now, we're gonna apply material to this. This thing is made of brass. We're told it's made of brass on that part. Okay. If you want to know the properties of brass in the lab, you can double click on this thing and it opens up. It gives you the properties, joint modulus, Poisson ratio, etc. Now I can't do it because My system administrator told me that I need a service pack because every time I double click on this thing, it crashes. But in the lab, I think they have already installed that. So not to worry about it. This lab there, this is there. So I'll just use the default properties. I don't need it now. Let me click on the floppy so that everything is saved there. All right. We know that there is a planar symmetry, and the way I did it, I managed to make sure that this is a planar symmetry. So I get there, I go to the split icon right there, and you select this vertical plane. It doesn't matter which side I pick. I say okay. Oh, geez, I forgot to do that bottom pocket. So let me control Z this. Let me control Z. Oops, control Z, control Z. Okay, good. On that vertical plane, I will sketch. Now, because I forgot to do this pocket down here, 11 inches this way, 3 millimeters, 11 millimeter this way, and then 3 that way. Um, this 22 is already taken care of because of that radius, no problem. So we go here, we draw a rectangle. Where am I? I'm going to go and draw it on, for example, yeah, okay, that's fine. On that face, or more view, on that face, draw a rectangle. We're going to clean it up, not to worry. So first of all, I want this thing to be on there. So I make it selected this, selected that with a control key, and I say coincidence. The distance from here to here is 11. From here to here is 11. The whole thing is 22. I think this is 22. Back there, it got out by accident. This dimension is 22. And the height is 3. Yeah, the height is 3 millimeters. So there we are. Exit. All right. And then we pocket symmetrically as long as we want. There we are. We say okay. There we are. This is the piece that was missing. And now we're going to split it. So where is the split? Split with this vertical plane. Doesn't matter which side we pick, and it's going to be right there. Okay. So let's save everything. Click on the floppy. It saves everything. This business of saving is critical because on the test, you have to give us the stuff. Incidentally, when you do finite element analysis, if you were to upload your results, submit your result to me for marking, it would be both the part and the analysis file. Okay? We haven't done the analysis file yet, but the part and the analysis file are must. Okay. So now we go to do the analysis, start. Where is that? Analysis and simulation, generative structure analysis. It's a default static analysis, and let's read the instructions here. Let me change the rendering. Okay, let's read the instruction to see what it says. It says, okay, use linear and parabolic elements. So I'm not going to do linear, I'll just do parabolic. Okay. Default sizes, make sure there is local mesh around all holes. Okay, half the size done by CATIA. So here's what I mean. Let's go back here, double click on this. The side is parabolic. I'm going to use parabolic. It says use linear and parabolic, but that's okay. Parabolic, half the default size. So half of that is going to be 1.85, right? Just remember that. So that's fine. So how do we do local mesh refinement? So here we have local mesh size on this and on that. Half of half of 3 point something, it was 1.85, right? And then we say, okay, notice that on this hole, and inside, and the other one doesn't matter because I'm not, I got rid of it by taking planar symmetry, is there's a local mesh slicer. Right click mesh visualization so that you can see it better. Right there, you can see that around this hole and around that hole, the elements are smaller, they're parallel. Okay, good. So you have to deactivate the mesh because otherwise you can't do nothing. Now this is a planar symmetry. So planar symmetry, you use surface slider, one there, one there. Means it's a roll. What else do we know? It says inside surface of this hole is clamp. So we go here, there's the clamp icon. You select inside surface, is clamp. And you are told that the pressure of 2 MPa is applied on that face. Please make sure you don't divide 2 MPa by 2 because you're taking half of the geometry. Pressure is pressure. As surface is already taken into account. If this was a load of 2,000 pound, force of 2,000 pound, then of course you put 1,000 here, 1,000 there. But this is pressure, so it stays as it is. So here's the pressure icon on that face, 2 MPa. Very good. Save the analysis file. File, this is what I was talking about. File, save management. Notice that analysis file that was generated is not actually saved. So because it says new, so select it, save as. In that folder, afternoon session, lab activity, I'll put down analysis, that's fine. And I say okay. And we're gonna run. So click on the floppy here or compute. And it's going to run. This is the warning message because of the fact that we use surface slider. It comes up. I don't know why they have it here. It should not be. Should have eliminated that. That's it. So this is not rocket science. When you do this thing, this is going to bend. You can see that. And these are going to stay flat because these are planes of symmetry. You put it on surface sliders. You can do animation if you want. Yeah, yeah. Look, these faces remain flat because you put it on roller or surface slider. Good. If you want to see numbers, you click on that. It shows you the numbers, but it gives you in the form of arrow. Double click on that. Use average ISO and change the rendering. The color is already there. You can see these lines, different color, but change the rendering to material shading so that you can see nice colors. And obviously, the biggest displacement here, 0.26 millimeters. Remember, this is a gigantic piece of steel, thick, 13 millimeter, 1 centimeter piece of steel. You don't expect a lot of reflection. But if you look at the stress, okay, so this is the stress distribution, 350 megapascal. Now, if this is a steel, let's think about it for a second. If this is a steel, uh, uh, the Young's modulus for steel is 200 gigapascal, right? 200 gigapascal. So that is 200 gigapascal. So in terms of megapascal, is 20,000 megapascal, right? 20,000 megapascal, 200,000 megapascal. Knock down 3 zeros, you get a rough estimate of the yield strength, 200,000 megapascal. Knock down 3, you get 200 megapascal. Ooh, look at this. This is 350 megapascal. So assuming that we trust these numbers, this point is going to yield. And when you think about it, let's see how much force actually we put in there, okay? The problem is done. It's just that we want to see whether these numbers make sense or not. So if you look at this area, this is 10 centimeter by, let's say, 3 centimeter. 10 centimeter by 3 centimeter, something like that, okay? And so that is, you can work it out. 10 centimeter is a 1 meter by 30 centimeter by 0.03, right? Yeah, 0.03. So that's 0.003 meters square. Okay. So if you take that and you multiply it by 2, this is meter squared by 200. What did I put there? 2 megapascal. So 2 times 10 to the 6 Newton. So that is going to be, see, 0.003 times 2 times 10 to the 6, work it out. That's going to be a big force, very big force in terms of newtons. So anyway, it doesn't surprise me that the value of the stress is that high. Okay, and of course, all bets are off because we're assuming linear elastic analysis, but suddenly the maximum stress is bigger than our uh, yield strength. Okay, so just be careful. It's very easy to generate good-looking garbage. Please work out the approximate yield strength or yield strength for check it out yield strength for steel. I'm pretty sure it exceeds that. Okay. I don't have a calculator here, so I'll leave it to you to decide. If they pay you to do these things, obviously you have just generating color is not no good. You have to sit down and see whether it makes sense or not. All right, folks. Good luck. That's pretty much it. Make sure you save this thing because if this was done as an exam problem, you not only have to give me the part file, you have to give me the analysis file, both of them. All right.